Good afternoon, ladies and gentlemen. It's my great pleasure to introduce Dr. Deng Li as keynote speaker for our Fintech, Artificial Intelligence, Big Data, and New Finance at our conference. Dr. Deng Li has been Chief Artificial Intelligence Officer of Citadel since May 2017. Prior to Citadel, he has been the Chief Scientist of AI, the founder of Deep Learning Technology Center, and partner research manager at Microsoft and Microsoft Research for 18 years, and also professor at the University of Waterloo for 10 years. He also previously held faculty positions at multiple places, including MIT, Advanced Telecommunications Research Institute, and Hong Kong University of Science and Technology. He is a fellow at many places, including the Academy of Engineering of Canada, the Washington State Academy of Science, IEEE, the Acoustic Society of America, and the International Speech Communication Association. In recognition of the pioneering work on disrupting speech recognition industry using large-scale deep learning, he received the 2015 IEEE SPS Technical Achievement Award for outstanding contributions to automatic speech recognition and to deep learning. He also received a dozen of Best Paper and Patent Awards for the contributions to artificial intelligence, machine learning, information retrieval, multimedia signal processing, speech processing, recognition, and human language technology. He's an author of, or a co-author of 6 technical books on deep learning, speech recognition, pattern recognition, machine learning, and the latest, natural language processing. So please let us welcome Dr. Deng to the stage and share his pioneer insights on fintech, AI, big data, and new finance with us. Thank you.
Okay, thank you very much. Thank you very much, Ding Zhi, for your very nice introduction, and thank you, Dr. Moore, who invited me to share my view on artificial intelligence as relevant to finance. So my topic here is, okay, from speech AI to finance AI. It's supposed to be from high-tech AI to finance AI. So I came from high-tech industry. So I have been working, for Microsoft for like 17-some years. I was overseeing a lot of AI projects over there before I moved to Citadel. That was about a little bit over 2 years ago. So I'm very new to, this is the first time I'm coming to this conference. So I really enjoy learning so much in the morning and in the afternoon with you. And last night we have a wonderful dinner, knowing many of the panelists and speakers. So I would like to, and I realized that a few of those actually attended my similar talk about 3 or 4 weeks ago at Credit Suisse conference. I gave very similar talk. So I'm just curious, how many people actually attended that talk? Just a few blocks from here. Okay, good. Not many of those, so I don't have to. So I don't have to change too much about what I'm saying. Otherwise, I don't want people to get bored. So from high-tech AI to finance AI, there is a transition from my personal experience as to how the high-tech AI, or sometimes we call the modern AI, that started about roughly 10 years ago, changed the entire technology industry. That started somewhere with Microsoft and Google and Facebook. And then now you realize that the industry has tons of new applications like autonomous driving. Without this modern AI, nothing could happen, right? And then a whole bunch of the product like Alexa, voice assistants, all the phones, a lot of apps over here, they're AI. They are very intelligent. They are able to do lots of things that nobody was able to do about 10 years ago. They all came from these new advances in modern AI, which I'll call deep learning. So let me just drive into the topic today, okay? Since this is a finance conference, I want to make as much connection as possible. Try not to bore you at all. Namely, first of all, the first part is try to give you some this kind of very different perspective. You probably have read this So the transformation of AI, transformation of a number of industries using the modern AI. So I gave you a few examples, like dialogue system. I don't know, that's actually has been used in the banking industry quite a bit over the last few years. It all came from this advancement of voice recognition as well as the dialogue, natural language understanding part. And then voice recognition, I will give you some, more detailed drive into that, and computer vision that actually propel the new industry called autonomous driving. It's all coming from the advances in computer vision. So I may not have much time to go through many of these applications. And the natural language processing, which is hugely relevant to finance industry in terms of alternative data in either quant trading or the one you heard earlier, and or in non-quant, areas of applications in finance. So I might be able to share a little bit about technical challenges in applying this new set of technology, especially in natural language processing in finance world. And then, of course, there's machine translation, robotics, and even search engine that Google just announced about 2 weeks ago, that the new search engine has been completely revamped using this deep learning. I don't know how much you feel the difference between the search engine over. I think they started switching a couple of years ago. That was just huge experience and changes. But anyway, so this is the first part. I'm going to very quickly go over that. And then the second part, I think this is something that many people probably will be more interested in, about how those technology coming from high-tech industry, namely the deep learning technology, may be applicable to finance, as well as some unique challenges from technology perspective, in the kind of application areas that many audience here would have interest in. I probably don't have much time to go through the third part, but there's some additional constraint that in financial industry we need to apply. So if I don't have time, I will skip that part. Okay, good. So let me start with some revolution for this AI. It roughly started about 10 years ago. So for those of you who don't know about AI history, AI started about 40, 50 years ago in terms of symbolic AI. It's an expert system, right? So, it actually failed miserably. There was a very big AI winter. That was before I was born, a long time ago. And then the second wave of AI revolution started roughly about mid-80s, maybe late 80s. That is based upon what's called the machine learning. So think about, many people actually ask, a question about last night, and people ask me, what's the connection? What's the difference between AI and, machine learning and data science, right? There is, data science, I'm not going to touch on that. It's kind of basis for everything, right? If you have big data, nothing like machine learning and AI can start. So think about machine learning. Machine learning, actually, the glory part of machine learning started somewhere about 80s, 90s. And from AI, historical perspective, we call that as maybe the second wave of AI. And that machine learning, that I know many of those companies have been using, including my own company before I joined Citadel. Those machine learning is something called what we call the shallow machine learning. And I'm going to define that, shallow versus deep machine learning in a different way. And then, of course, about 10 years ago, somewhere starting from this time, then sort of there was a new trend of machine learning. It's called the deep learning. Namely, researchers in machine learning realized that the shallow machine learning that was very popular in 90s and starting from late 80s to 90s and all the way for 10 years before this modern machine learning started about 10 years ago. And they realized that there's a huge amount of limitation about the traditional machine learning. And those machine learning was sort of driving voice recognition, computer vision, and none of them actually work. I mean, so about 20 years ago, 10 years ago, when the shallow machine learning was very, very popular, you never saw any good product coming out of those, okay? Including Microsoft, including Google, including, I think Google just started, so many years ago. And Microsoft has been around for a long time. We have been driving shallow machine learning for many years, including my own work at Microsoft. Actually, after I got fed up with, academic world. Actually, at University of Waterloo, many of those, people I know come from Canada. So, in the sense that the old days of machine learning just couldn't have enough capacity to absorb large amount of data, even if you have a large amount of data. And for many other areas where you didn't have enough data, then machine learning just could never work to the extent that it can go to mainstream industry. So about 10 years ago, and then actually modern machine learning originated from Canada, from Toronto area, like Professor Jeff Hinton, now a whole bunch of people who got Turing Award, like Nobel Prize. The latest all come from Canada. So, yeah, so I really have to make that work well. Okay, good. So just let you know a little bit about this, how the modern machine learning, modern machine learning or deep learning or modern AI, they all mean the same thing, okay, for this talk. So I'm not going to talk too much about shallow AI. And although I know most of the finance companies are still using standard shallow machine learning, like logical regression. You do tons of support vector machine. You're still working on those. I mean, the whole purpose of this presentation is to convince you that you have to think about, your way of, and there are a lot of machine learning theory developed in, 10, 20 years ago. Many of those have been outdated. I'm going to show you some modern way of viewing those technology from the perspective of success in applications. So the previous slide shows you that conference. Well, it's called NIPS conference, and that's the conference that's very, very popular. Like 10 years ago, it wasn't that popular. It's about 1,000 people, 2,000 people. That's the at most. So you can see that since that 2009, 2010, the number of attendees of the conference just exponentially growing. So as of last year, the attendance goes roughly about 8,000 people. They are all the best students, the best, academic people, as well as the industry people. And most importantly, all the major finance companies, especially the hedge fund companies, when they set up a booth to recruit, PhDs from Stanford, PhDs from Berkeley, PhDs from, and they're all in computer science department. Occasionally, statistics as well as engineering. And then this year, it's going to take place in Vancouver again, about 1 month from now. So, and then of course, all the tickets have been sold out. So last year, this is the number I got from last year. This is an article from Forbes. So within 12 minutes after the sort of registration opened, they're all booked. So it's extremely popular. Most of the people didn't get a chance to register. So, but anyway, so you can see the number of papers goes exponentially. It's very, very popular. So the whole field of deep learning and modern AI is growing exponentially. Sometimes people, last time I gave this talk, I think Credit Suisse, some people ask, so look at that, the last year is flattened out, right? It doesn't go exponentially. And the reason why is because they didn't have enough room to host them. So this year they put them into Olympic, conference. So there will be a lot more. I don't know how many people eventually register. But anyway, this is a very popular conference. And actually, in one of those years, I pointed out the arrow there. This is academic conferences. This is one of the major academic conferences. And then Mark Zuckerberg shows up all the way. That was about 2013, and announcing that he's establishing Facebook AI research and hiring a group of people from there. They negotiated out already before they went out to make an announcement. But it's very popular, and then a lot of high-tech company executives, they just love, to get people from there and then to learn all this new advanced from there. So I myself have been in this conference for over the last 25 years. So where do I post here? Okay, good. So let me go back a little bit about the history of this voice recognition high tech for, that eventually lead to the current status of, being very, very popular. So this is the very first time around 2012 when New York Times first reported the success of deep learning out of the work done at Microsoft. And then that work is actually between Microsoft, I was part of the leader in this research together with a Canadian academic, Professor Jeff Hinton, And then academic, of course, they love to win awards. And then for our industrial people, we love to make a real impact. And then we actually, after deep learning disrupted this voice speech, technology, as well as some other technology, I decided to move to solve more difficult problem in finance. I'm going to tell you in a moment why it's more difficult, and to make you feel good that you are dealing with a very important problem, which requires more than just a standard machine learning that many of you have been working on, especially on the quant world. Right? So in the quant world, I actually have been involved in over the last 2 years or so. I actually got a lot of experience as to what people have been doing and why many things do not work well, and what kind of things that might actually help. And of course, I won't be able to tell you exactly how much gain we got. That's the kind of things that's very different between high tech. Because if I were to talk about this one in high tech, for AI conference, I'd love to show you, how much you gain we get. But for this kind of conference, I know this is one of the cultural shock to me. Right? But okay, Okay, so this is the architecture. For anybody heard of a neural network here? So deep learning essentially is a very, highly hierarchical with a very deep architectures in neural network. And there are other type of machine learning model, non-neural network, they can also be called as deep learning if they have very high, complex hierarchy. And so, but most of maybe 90% of this deep learning came from neural network. So in the old days, neural network couldn't be deep because otherwise you will never learn how to do that, how to learn the neural network parameters. So typically neural parameters, they typically about a few million parameters. That's very common. And then you need to have, a lot more data to train them, right? And although more recent work, many of those actually came just published within the last 1 year, even actually show that even for small amount of data, you can still get very, very good performance. But you have to do a lot of careful, design of the architecture. But anyway, so on the left-hand side, it is the neural net architecture for dealing with the voice or speech recognition. It's a sequence data, and many people think that, well, speech data is a little bit like market data. It's a sequential time series, and actually nothing can be further away from the truth. Anyway, that's a different story. And then due to the use of this type of architecture, the voice recognition error rate just dropped dramatically. I mean, look at, there's almost 10 years of the time up before deep learning, sort of succeeded about 10 years ago. Roughly about 10 years, the error rate just stayed more or less the same. It's just like when you PNL, just get stuck. Well, actually, even if PNL gets stuck, it's still positive, right? But for error rate, it gets stuck. That means people just couldn't make use of the system at all. And until deep learning come along, and then MSR, this is the first experiment we try, it dropped error by about almost 30–40%, and then the error rate eventually dropped down less than about 2 or 3%. And that's why, your dialogue system, now I don't know how many of you actually are using the, voice, the dialogue system. You talk to the bank and you get all the results coming out automatically without having to talk about it. And some people don't like it because it's not because the voice recognition is not good. And you normally don't find any errors, right? It's just the database is bad, right? Sometimes you get a problem. Sometimes understanding is bad. It's not just the voice recognition. But anyway, so that technology is almost as good as what human can listen to. But human has some intelligence to think about how to get an answer to you. That's a separate story, right? So there's a voice recognition part, and there's an understanding part, and there's a dialogue part. And that the understanding part is still active research going on. And I believe that within maybe a few more years, you probably can get much, much better result in terms of understanding. And I'm not saying that it's going to replace human, but at least technology is moving towards the direction that you can expect machine can slowly replace more and more people to make people like you guys to focus on more intelligent kind of work, like analyzing the market, like very much like what the panelists talked about last time, right? And a lot of things that the previous analysts, the panelists discussed, probably wouldn't be replaced by machine, at least for 10, 20 years, maybe more. So the job is good. And then people, of course, publish all these, hugely influential papers. Let me go quickly. So this is, so now I'm going to get back to finance a little bit more, okay? So before I get back to finance, I give you some survey about, it's a very, very high level view about what voice recognition system works, okay? So, so basically you have various parts, components, right? And one part is what's called acoustic model. That means, I talk and it goes into phoneme sequences. And then you get a different component called a lexical model that can put together all the phoneme sequences into word sequences because the dictionary tells you what they are. So for different languages, you have different kind of, the reason why I talk about this is because eventually in finance, we probably will talk about something related to applications. And then for language model, it actually computes the probabilities of one word following another and following another, And then after you put them all, these components together, when you talk, all the sentences coming out automatically, right? So that's not easy problem, right? And that's actually quite different than financial, time series prediction problem. For financial market prediction problem is that you take into the input to be the past history of the market data plus whatever, alternative data, you extract features and then you do prediction. And that, that's what quant is about, right? Whereas in voice recognition, you actually have the time sequence input and the output is the symbolic sequence associated with the input, not the future. Right? It's a very different problem. Okay, but anyway, so for those of you, a lot of people ask me. Oh, okay. Now I'll go really quickly. Okay, so now this is the diagram for quantum research. So that's as much as my company would like me to talk about quant. I think everybody will know that there's an alpha model, there is a risk model, there's transaction cost model, you have optimization components, and then you get execution, right? So I think many of you have been working on various components. So one of the key success of voice recognition was to use the neural network for all the different kind of components. And that just gives huge amount of error rate reduction. So of course, naturally, people will think about this kind of philosophy that might inspire how quant research may be conducted in terms of how to integrate components. But if your components don't use the neural network, it's very hard for you to put different components together to get end-to-end learning experience. So that's, I'm going to go quickly. I saw, well, I'm surprised that my time is so limited. So actually, this talk can last for 3 hours. So I'm going very, very quick today. And then I'm going to spend a few words talking about natural language processing because this is a very important, actually it was impacted very, very heavily by deep learning. And then it has a huge relevance to finance world in terms of how to understand using machine to read news, to read financial documents. And then I think this morning there was a panel talking about this aspect of application. I fully agree with everything said over there, except now I give you a little bit tools for you to accomplish some of the things that you heard this morning. So this is a dialogue system. I don't have time to go through all the things, except to let you know that almost every single component of dialogue system is now deep neural network. And that's the state of the art. It actually wiped out all the previous shallow network, shallow machine learning completely. So if you go to this conference next month in Vancouver, Canada, about maybe 9,000, 10,000 people there. If you talk about shallow model, people don't even pay attention to it anymore. Okay, you talk about neural net, everybody goes in there. It's just opposite about 10 years ago. And 10 years ago, when you go to, if you publish a paper in neural network, it's automatic rejection. Right? So it's just completely changed. I mean, the whole title will changes. So everything is neural network. So every note that I saw here, I drew over here. Okay, this is coming from the book that I wrote. This is actually the last project I did at Microsoft before I left for Citadel. So, and then the next, so the next component, this is called machine translation. Again, everything is done by neural network, and everything is done by nonlinear modeling. So in old days means about 4 or 5 years ago, a lot of people think that, nonlinear models are very hard to learn. Now with the neural network, there's so much open source, programs available from, Google, from Microsoft, from all the academic as well as the industrial research. People in high-tech industry just love to open source their, their programs. And the company are happy to let them open. Do you know what's the reason for that? Anybody? So like 20 years ago, people didn't want to do that. It's only about 10 years ago. It's because of talent, fighting for talents, okay? So if you actually establish that you are like Google and Microsoft, we fought quite a bit for talents. Also, it's a way of encouraging, employees to really contribute more. And then the reason why it doesn't hurt the business as much as open source in finance industry. In finance, it's almost impossible to open, right? If you open everything, they shut it down right away. It's because the business model for most of the high-tech industry really come from the internal data. They have, Google has its own data, Facebook has its own data, although they don't do its data in the right way. Right? And Microsoft, I still love Microsoft, and Microsoft use the data really responsibly, but we don't share the data with others. We share the programs, we share the technology, and therefore, and that really helped my team. Right? So my team is still there. All I have to do, I just hire a small group of hackers. And they look at, since we understand technology just in depth, anything I take a look at the paper, and I take a look at the open source, we know whether it's going to be helping me or not. Right? It just, it took me about 10 minutes. I probably can make that assessment. So we just get all these hackers. I hire the people who can close their eyes, can do all the programming. So extremely fast, extremely quick, and then the result will come out, just faster than, even when I was at Microsoft. Right? In finance world, we move very fast. So this open source movement, due to the openness about the source code from the new technology, really help, my team to make very fast progress. And another thing that I want to mention over here is that the technology developments now, when they want to publish their work in AI conferences, AI papers, they have to pass the bar called the reproducibility. If you don't do that, the paper gets rejected immediately because it's so competitive, right? Everybody, a lot of young people, Stanford PhD, Columbia PhD, they want to be famous, right? So fame, it's just as important as wealth, right? For those young kids, in computer science, and Waterloo as well, Toronto, they are willing to spend so much effort to make the experiment reproducible. Therefore, there is a test. For the review, they actually would like you to post something first. So if other people cannot duplicate your result, it's just rejected. And that really put the bar really high and also make my job much easier. Okay? So if I look at it's duplicated, that's fine. Otherwise, I spend effort there, putting resources there. At the end, we couldn't duplicate it, and the paper sometimes get accepted. That happens all the time, right? So really, the bar is very, very different than different companies. So I'm still keeping track of all this. So anyway, so this is machine translation. So the next application in natural language processing is called question answering. That's all done by neural network. So if you look at all these complex diagrams, don't worry about it. Once you understand the algorithm, you don't even have to write the code. Just go to TensorFlow. In Microsoft also, we have open source, PyTorch. And then, of course, you have to understand. So that it really put the burden on the, the understanding the essence of technology now become more important than, being able to code to correct, the errors. It's just a completely different way of thinking about technology nowadays than just a few years ago. So this is a question answering. Question answering, do you know how it should be very useful for finance, right? So if you are, I won't tell you details. On the sentiment analysis, everybody knows, right? If you don't know, then you probably wouldn't be in finance here. So let me quick. And then there's another one called the image to text translation. So this is amazing technology, right? It wouldn't be possible just a few years ago. So basically, you take a photo, and they use exactly the same technology as what I showed you earlier. You actually can describe, the computer will automatically write up what is contained in the photo in terms of sentence, in terms of paragraph. And that's just mind-boggling. Right? The first time I saw this result, I couldn't quite believe this one can be done so easily. I thought that maybe whatever sentence generated will have grammatical errors because it's neural net generate, to generate sentence. It's not easy problem, right? When you do sampling, it also does some sampling. It turns out the sampling almost never get wrong. But anyway, so this is, my time is quick. So I'm spending very quickly about 3 key challenges to apply all the things I talked about earlier until now. What kind of difficulty you want to overcome in order to make them successful in finance industry. So number 1 challenge that at least I face, my team face, is the heterogeneity of big data. We often call alternative data. Now, for high-tech industry, typically, when you work on a project to solve a problem, it's typically 1 or 2 types of data, right? So either if you do machine translation, the input is text data, right? You get French as the input, and the output is English. It's the text data. You don't see, very different type of data, right? And then for voice recognition, the input is voice acoustic, and the output is text. 2 types of data. And then if you are doing image, or the captioning, the one I show you, the input is the image, is camera, and the output is text. That's it. Whereas in finance, the data is much more diverse, right? And for those of you who know alternative data, it has the text data, the news you read, and also if you read all this, alternative data literature. Okay, 5 minutes. I don't have time to finish that. Like image data also has been in use, like satellite imaging data. This is all open, so I'm able to tell you about this. Now, for example, if you take the image data, satellite data to see, wow, Walmart parking lot has more cars than Target. Then you kind of know. It gives you some alpha, right? That something is better. Like 5 to 10 years ago, the analysis of image wasn't good enough without deep learning. So now, the image recognition was just having a huge progress since 2012 by University of Toronto's researchers on deep learning, and then they applied that deep learning technology soon after applying that with me and Microsoft on voice recognition and natural language processing on a standard Stanford database. It's called Professor Fei Li, and then she curated this large data called ImageNet. And that deep learning just showed tremendous, basically cut error by almost half. Just within just a few months of work using deep learning. And that dramatically changes entire industry. So everybody shift into doing deep learning, and then the error rate dropped down for image recognition error. Within 3 years, it dropped down below human image recognition, and that propelled entire autonomous driving industry. So now, so that's one of the things I just mentioned. Before many people who are not in this technology still think that autonomous driving is dangerous in case you take your hands off, you hit somebody. No. They read things much better than human would do, right? And human, you get tired. Even you don't drunk, right? You don't get drunk. Sometimes you get tired, but now, computer vision is just so, and then also it changes entire sort of image, sort of medical diagnosis in the industry. So I don't know how many of you read, all these, very famous papers that if you take the photo about your skin here, so the computer will tell whether you have the chance of having, skin cancer much more accurately than the best doctors who can do it. Why? Because all the data are available. Because of course, when you train that deep learning system for image analysis, you take into account thousands of best doctors in the output. Right? So you label them right or wrong. Okay, either positive or negative, and then you actually aggregate thousands of doctors' intelligence into one machine system. So actually, AI system. It's not just purely machine, right? It takes into account human expertise in the training. And once you took into account the training, you move into the system. Of course, at the end, when you apply them, it sounds like just a machine. But when you do the training, typically you need to have a human intelligence built in there. So, but anyway, so that's the first part of heterogeneity problem. So image recognition now it's so good that you actually take satellite image, you can tell a lot of things what's going on. Like oil, whether truck is coming out of the oil field. And then like 10 years ago, you couldn't tell whether there's oil in there, right? Now, image analysis is so good that you actually can tell exactly what kind of things, whether the oil, is half, full or, all these things become possible. And then this is the alternative data statistics. So alternative data covers more than just image, speech, and text data. It also covers, the search data and then apps data, as well as now user data as well. They are all part of the this heterogeneous data, and a lot of alpha signals coming out of research and make use of all this data. And of course, in addition to all this alternative data, you also have the data of fundamental data, right? Your earning data, many of the you are very familiar with. In the prediction of fundamental data, they are what's called the categorical data. They are symbolic data, and some of them are numerical data. And also you have market data, which is numerical data. So all these data are combined to enter into financial, market prediction. And so this is the kind of diversity of the data in use. It's not something that high-tech world was, very much used to. So I won't tell you how much GPUs we bought at Citadel. Well, perhaps I can tell you, it's probably more than what I bought at Microsoft. Anyway, but we use a large amount of machine learning, large scale of infrastructure because of this, this heterogeneous data problem we need to solve. And in terms of technology, we're very, very lucky because the neural network is inherently amenable, it's naturally suited for getting heterogeneous data because you have many layers in the neural network. At certain different layers, different types of data in alternative data and market data get integrated. If you have shallow model, you're out of luck, right? You get over what's called the overfitting very quickly because you don't have any capacity to combine different kinds of data. So being deep, being able to design the right architecture to integrate different sources of data is one of the very big challenge in applying deep learning and modern AI into finance. So the second, so let me go quickly. So the second challenge is what I call the low signal to noise ratio problem. Okay, come on. Okay, so this is a very high-level description of the problem, right? So I think this is the only equation that I'm allowed to use here, which is by definition what signal to noise ratio. It doesn't tell you much about this. So in high-tech world, we literally apply that signal, that formula. So for example, if I want to solve voice recognition problem, I actually can measure what is the signal power, right? So I basically just take a microphone right in front of me. That's a clean signal. And if I take the signal, the microphone in the back of the room, it's a summation of the reverberant, some noise together, and then subtract what I say. And then whatever left would be the noise. And then you can compute signal to noise ratio. And then it turned out that now with the deep learning, the system can handle roughly about 0 dB signal to noise ratio. That means the noise power and signal power about the same. Voice recognition still can work well, okay? Like without deep learning, typically you have to have about 20 dB, at least 10 times more signal power than noise power in order to make it work. If you add noise, usually break down. But now, now in finance data, you don't have the formula to compute this way. Somebody figure out a way to quantify signal to noise ratio, that'd be wonderful. But give you an example. The signal, what's the signal? Signal, so there's input and output, right? So the output talking about market prediction, okay? Market movement prediction. So, for the output, actually to me, the real signal is the intrinsic value of certain companies, right? And then the real market that you're measuring, to me, many of those are noise, just like what Warren Buffett would say, right? Like if you get some tweet from our president, and then all of a sudden it go up, and then 2 days from now, he make another tweet, it come down, and then come back to the same thing, right? You should treat that as a noise, right? That's what Warren Buffett would say. And And then if you just use the market data as your, your predictive target, you are subject to noise, right? Because in reality, you really should do what? You should get the signal coming out of Warren Buffett's mind, and then of course, it's very expensive to do that. And then one of the challenges for AI to apply to deep learning, to finance, it will be able to clean up the signal, and that's the output side. And now for the input side, the signal, the noise level could be even bigger. For example, fake news, okay? And that's a very big, and then of course you have to solve the problem in order to make use of AI to handle, the news. Otherwise, you get fooled by whatever wrong data. So you get the bad data, you get the bad prediction. So these are all the kind of problems that modern AI should be able to handle. Now, in finance domain, I think the challenge is it's actually even bigger than in the political, domain. Because if somebody gets fake news, people get arrested very easily, right? In finance, it takes a while. But anyway, so that's a different story here. Okay, and now, so now how do you combat this noise? So I'm going to share with you this modern technique that has been around in the media over the last few months, maybe more. It's called deep fake. And then this is very, I can spend the whole hour talking about this slide. But the logic of this slide goes as follows. So I don't have much time here. So there is a very, very important technology developed over the last few years. It's called the adversarial, a generative adversarial neural network. And that's a special type of deep learning neural network. And the whole point of that network is to be able to distinguish. It's a genius design. So you have two objective functions. It's like, people are fighting with each other. And that's, if you look at, so essentially, one network generates image, okay? And of course, if you don't train the network well, whatever generates, it will be garbage, right? And then there's no. You don't just generate them using random weight. You learn the weight in such a way that there's a separate neural network that distinguishes whether it's a fake or real. And the neural net is so powerful, it can distinguish them well. And then you have label data. Whether it's, if it's a fake, it's a fake, right? It's real, it's real. And then you learn them back and forth. At the end, after you reach the convergence, the fake and the real are very similar to each other. And that's the whole, and that philosophy has something to do with handling adversarial properties, characteristics in financial market. There's a lot of adversarial, like competition, right? In finance, it's a lot more. It's a lot more than in high-tech industry. In high-tech industry, if I and Microsoft develop voice recognition and translation system, I don't worry about our competitor, like Google, like Facebook. They develop similar system. They are not going to corrupt my data. Right? I train my data. My data is is mine. Right? I train them. Whereas in finance world, it's very different. Right? You have built a system, and the system behaves a certain way. And then the adversarial nature of a competition, because it's kind of zero-sum game. Well, I have a lot of debate with my colleagues whether it's a zero-sum game or not. Of course, my view is the short term, of course, it's zero-sum game. Every time you get zero-sum game, competition really, force you to, to overcome the non-stationarity, environment very quickly. Whereas for long term, it's not what. I'm not going to go into the detail here. But whereas in high-tech industry, this problem, the reason why people develop this type of adversarial networks, it really is because for political environment, for this problem, like I don't know how much you follow this kind of news, right? It's just huge big news. So we can actually there was some demo in some of the conferences that I attended. Like Obama, you can make him just behave the same as you see him on the TV and ask him, Kelly, the technology is just big enough. Some of the image you see could be fake. And then now, so the reason why I brought up, I tell you that it takes a whole hour to explain all this, it's because now the cure to this problem come from the same algorithm. If I know your strategy, I can design my algorithm to detect you are making this kind of problem. Does it sound like finance? It does, right? But anyway, so this is a very big technology. It's called GAN, Generative Adversarial Network. If you don't know about this technology, maybe it's worth it to take a look at, especially if you need to deal with the fake news problem. You need to distinguish real human-made versus the natural. All the things, people are just so smart. The modern AI is so smart that it actually creates a problem. And now the people who created this technology now are working on how to fight against this kind of problems. So, so I was involved in this kind of work because, finance problem does eventually, maybe not immediately, will encounter this type of problem. Give you a little bit heads up. Okay, that's all I want to say, except the last item. I just very quickly to let you know that those are not part of AI per se, but in order for AI system to be effective in finance industry, we need some additional problems, and I don't want to dwell on the detail, except I want to emphasize that the talent challenge, the shortage of talents is one of the main problems that at least I am facing. So my company, I'm actually building a team, AI team in Seattle area. For those of you who are really passionate about this, challenge, come to talk with me. So my criteria is actually, I interview, if I interview 100 people, typically about 3 or 4 are actually meeting my criteria. And we need to have the people who are not only to have, very, very solid, technology, skills, who understand, who can be very, very sharp, quickly, and also hands-on to implement the technology, to understand the essence of technology. But also, we would only hire people who, in addition to those skills, but also have deep insight to finance problem. It's very hard. So we actually, so that's one of the reasons I went to, Stanford, Berkeley. I gave quite a bit talk. If you go to search for YouTube, you can see some of the talk. It really is just to promote them, to make them, to be able to train such great, with combined skills. It's not that easy. Some people come to my team to learn how to do that. It's too slow. So we, but before we have all this, talent trained, actually I visited Columbia University, and just last year, some of my colleagues at Microsoft went there to be the dean, to be, and they said, oh, that's impossible to train. So if it's impossible to train, we trained it, within my team, within my colleagues. But it turned out that, some people just not suitable. Why? Because it's very intense. You have to have different skills. And this is the problem that you heard earlier in the morning, right? Some of these talents. So, but anyway, so that's, I want just to let you know, I mean, if you get 1,000 people here, maybe 1%, that's good enough, right, for me. But anyway, thank you very much. I appreciate your attention.
So my question is about applying AI or machine learning into financial world. You talked lots about the example, but how about the scalability and the maintenance? When they actually go into the real world, what's the cost in the initial and then continue? Yeah.
Yes. Yes. Machine learning requires modern AI requires a huge amount of computing, especially in financial world. And that's why one of the reasons I think it makes sense for big firm to do that more to start with, right? Maybe spread out, the success for small companies. So without big computing, it's very hard to build, that kind of system. Although some academic research now I read recently, they try. Well, there is a very interesting technology. I don't think it's mature yet. So you build a very big machine learning, system to be able to have very, very, accurate prediction but not for finance. I'm not talking about finance. Okay. Well, I mean, just share with you some of the things that the modern development in high-tech world. And then you can think about how, of course, I thought about, I'll probably think about first. I haven't got a chance to think about carefully yet because we haven't reaped all this fruit yet using large systems so far. But for those, you might, for those, for PhD thesis, for maybe interns, you probably can look into this area of research. So one idea, and this is a very good idea, in high tech it's wonderful, especially, and the motivation for this research is to be able to put that large system in the phone, okay? For the phone, it's like, small company, right? You can put all those big machines over here. So one beautiful technique. It's actually, I put that in one of my slides, one item there. I think it's time to elaborate in detail. You build a big system which get very accurate prediction for, for voice recognition, for image, for natural language translation. And then you take part of that information, and then you make the predictive, the target to be the new target to train a small system. Okay? It sounds a little bit crazy, right? You know why? Because you think that the whole point is that if you use the small, you want to have a small machine learning model in your phone, then it's not able to absorb large amount of data. So I don't know if you know machine learning theory. So large amount of data wouldn't work well if you have a small system, right? Because you just saturate all your data. So ideally, you make it big. So there's one little trick that you can make that happen is that you just simply copy whatever you train as the output, which is noisy, right? Because output could error, maybe 10% of error, maybe 5% of error. You use the error flow signal to be the new target to train small system. It does much better than just train accurate with the accurate target and large data with the small system. And then there are a lot of papers on that. And in the beginning, it's very hard to understand, right? So there are some theories to analyze why that happens. It's universally true. But for finance data, we do have a lot of data, right? So maybe it takes a while, for a big company to look into that possibility. But it's a very solid result. And then maybe, for small company, if you don't want to do that, you might actually be able to get, reasonable gain. You will never be able to get as big gain as a large data, large system. But since you don't have large system, right, for whatever reason, either you cannot afford to buy GPU to train, you might as well make use of. For that case, you have to go to university. A lot of universities do have a lot of GPUs, right? Especially good universities. That Columbia, they have lots of GPUs. And you can use them, to train your target using your big data and then copy whatever coming out of that system to be the fake target, which is not accurate target to train small system. And the result will be surprisingly good to you. It's not intuitive, but this is one, but actually fit into machine learning theory well. Okay, thank you very much.